Okay, let's start today's lesson. Today I'm going to start a new lesson called friction. Friction 1 day lesson. So definitely for your A-level question, there will be friction part for part A. Part A applied paper, there will be question, usually question number 7. Usually question number 7 will be, question number 8 will be friction question. Very simple question. Then I'm going to start it today, and today itself we can complete that. Okay. Now write down topic friction. Now write down topic friction. Friction. Okay. Okay. Now see this and all. See this and all. So you consider smooth surfaces. So if there's relative motion between smooth surfaces, we don't have any frictional force. We don't have any frictional force. But when we consider rough surfaces, if there is relative motion between rough surfaces, there will be friction. That opposite to moving tendency. That opposite to moving tendency. Okay. That friction depends on the surface nature of the surface. Okay, and the reaction of the body. Then when we consider a smooth surface here, consider this particle here, mass simple m. I'm going to give a force capital F. Force capital F. Then here no frictional force. No friction. But there's acceleration A. Here acceleration. Acceleration. So when you consider F equals ma, Newton's law, then F equal mass into acceleration, then A value equal F divided by m. Surely there will be a friction. There will be acceleration, an acceleration. Okay? But when you consider a rough surface, you consider here there's a particle of mass simple m. Mass simple m, I'm going to give a force P. Okay? Here gradually increase in force. Let P gradually increase in force. Gradual increase in force. Gradual increase in force. Okay. So then here the rough surfaces, therefore frictional force will appear against the moving tendency. Okay, frictional force will appear against the moving tendency. Moving tendency. That's surely opposite to moving tendency. Then you consider here reaction R. Reaction R. Here mass m, no? Then weight mg. Mg. Weight mg. Then for gradual increase in force, for some instant this particle won't move. Particle won't move. For some instant that particle won't move. But sometimes later it can move. It has moving tendency. That moving tendency position, that the limiting position, we call limiting equilibrium. Before that we say static position. After that we say dynamic position. Dynamic position. So all the things under physics you have learned. Okay. Then you consider here given force P, here frictional force F. Here friction. So for some instant given force equal to frictional force. So that is proportional to the given force. Here this one at this instant we call maximum friction. Maximum friction. Then later for dynamic friction, someone less than maximum friction, it is constant value. Here this is limiting limit in here this part statics and here this part dynamic part. Okay, then dynamic friction constant value. Dynamic friction constant value, let's say FD. Okay, this is about friction. This is about friction. Okay, just write down this. Just write down. Let a particle, let a particle placed on a rough surface, placed on a rough surface, placed on a rough surface, and a gradual increase in force P and a gradual increase in force P, gradual increase in force P is given to the particle along the surface as given the figure, as given the figure. As given the figure. Okay. Now you sketch this one. Sketch this one. By the side you put this, write this one as well. Huh? So now you sketch and write all, and by the side you write this one. This is for smooth surfaces, but here we don't worry about smooth surfaces. We only concern about rough surfaces now. Okay, now just write down, with star mark write down. For smooth surfaces, no frictional force will appear. For smooth surfaces, no frictional force will appear. No frictional force will appear. Next line, star mark. When there's a relative motion or moving tendency between two surfaces, between two rough surfaces, the friction will appear. The friction will appear. The friction will appear. That force always against the moving tendency. That force always against the moving tendency or the motion. Next line. A force capital P is given to the particle as the figure, which is gradually increase in force, which is a gradually increase in force. gradually increase in force. Then the nature of the body then the nature of the body may change with the value of p, with the value of p. For some instant, the particle won't move. For some instant, the particle won't move. That means the frictional force, equal and opposite with the given force. Sometimes later, the particle has moving tendency. That position is called limit in equilibrium. Right? Put stomach and write down. At the limit in equilibrium, the maximum frictional force will appear. Maximum frictional force will appear. Next line. Later, the particle is moving. Then the dynamic frictional force will appear. This dynamic friction is a constant. Okay. Now see this one. Okay, you better sketch with me. Here this is rough surface, a force P given, here reaction R, then opposite to the motion there will be friction, then here friction, reaction R. Then we say F divided by R coefficient of friction. Coefficient of friction usually denoted by mu. Here usually denoted by mu. Okay. Then here friction, here reaction. So when you consider resultant value, here say R dash, resultant of R and F. Resultant of R and F. So here the angle between R and R dash we call lambda. Lambda we say angle of friction. Angle of friction. Therefore tan lambda equal F divided by R. No? F divided by R. Then tan lambda represent mu, coefficient of friction. Mu. Coefficient of friction. Okay, coefficient of friction. Here you identify, here reaction, here the resultant, then angle between resultant and the reaction, angle of friction, and F divided by R we call coefficient of friction. Coefficient of friction. Then tan lambda angle of friction, tan lambda F over R. So when we rotate this one like this, so we can create a cone. We can create a cone. We introduce that one as cone of friction. Cone of friction. But about cone of friction, we don't consider. But there's a cone of friction. Okay? Okay, put that one. Put that one. Okay, now just write, with star mark write down. The F divided by R ratio, the F divided by R ratio, the F divided by R ratio is known as coefficient of friction. The F divided by R ratio is known as coefficient of friction. It says that the frictional force is directly proportional to the reaction. It says that the frictional force directly proportional to the reaction. Directly proportional to the reaction. At the maximum position, just about to move, F divided by R is known as limit in coefficient of friction. Limit in coefficient of friction. And for dynamic region, which is known as dynamic coefficient of friction. Dynamic coefficient of friction. Prishnama can write down. The angle between reaction and the resultant of F and R is the angle of friction within bracket lambda then tan lambda represent angle of friction, coefficient of friction. Tan lambda represent coefficient of friction within bracket mu. Coefficient of friction mu. Okay. Now see this one again. You consider this particle here that placed on rough surface, gradually increasing force given P. Here reaction R, here weight mg, and here friction. So when it is in limiting position, that has maximum friction. No? Let's denote by Fm. Then limiting frictional force. Limiting frictional force. Okay, limiting frictional force that is greater than general static friction. This is static friction. General static friction. Okay, then limiting frictional force surely greater than general static friction. No? So you consider a parallelogram like this, reaction won't change. Here consider this one. Here Fm divided by R, let's denote by mu m. That is limiting coefficient of friction. No? Fm over R mu m, limiting coefficient of friction. Limiting coefficient of friction. So you take this angle lambda, angle of friction. So for statics case, now resultant look like this. Now take this angle alpha. Then when you consider Fm divided by R ratio and general F divided by R ratio, R common, no? Then Fm maximum, then the general friction less than Fm. Therefore surely here we can see this type of inequality. No? For some cases, here F can reach to maximum. No? Therefore, it can be equal. Then here mu m greater than or equal F divided by R. Here this is we call greater than or equal F divided by R. We call equilibrium condition. That is we call equilibrium condition. Okay. So you have to remember that one. That is very important thing. That directly deal with available questions. Mu greater than or equal F divided by R. Here equilibrium condition. Here usually we put modulus sign. Later we will discuss why we put modulus sign. But for now you just identify there can be modulus sign. Okay. Then when you consider lambda and alpha relation, then lambda value greater than alpha value. No? Same represent lambda greater than alpha. Lambda greater than alpha. Then when you rotate this sun, we create a cone of friction. Here we can create a cone of friction. Therefore, general resultant inside that cone. No? Here general resultant inside that cone. Then only that is in equilibrium. then only that is in equilibrium. Okay, put that on. Don't worry about everything, but you remember this one, mu m modulus F divided by R. So we need to consider that. Okay, usually this general static coefficient of friction will change, okay? Time to time it will change. General statics coefficient of friction. But limiting coefficient of friction, that won't change. Limiting coefficient of friction won't change. That is the maximum friction, coefficient of friction. Okay. Now mainly here we consider about equilibrium of a rigid body part with friction. Equilibrium of a rigid body part with friction. Therefore, the body is in equilibrium, no? Then no resultant, no moment. No resultant, no moment, no? Then we can consider that equilibrium condition always. We can consider equilibrium condition always. Okay, now write down. Here we mainly consider about equilibrium. Here we mainly consider about equilibrium. About equilibrium. Therefore, no resultant force and no moment. No resultant force and no moment. Okay. Okay, now let's start questions. Take your tutorial. So let's do few small questions and later we can move to exam standard questions. Okay, take your tutorial. Okay, you do with me. Page number 2, question number 1. Start from question number 1. Just do with me. These are very small questions. Let's do one by one. A horizontal force P applied on a body of mass 6 kilograms, which is on rough horizontal plane. Here rough horizontal plane, mark forces, 60 Newton, mark reaction, then force P given. When P is gradually increased, limit equilibrium, then here there will be friction. So at the limit in equilibrium, F equal P. Then F value P given 15 Newton. Here, this is limiting frictional force. Limiting frictional force. So when you consider vertical equilibrium, R equals 60 Newton. Then here 15 Newton. Here not asking coefficient of friction, but let's find it. Then mu F of R, 15 divided by 60, 1/4. Here limiting coefficient of friction 1/4. Okay, continue. These are small questions. You continue one by one. Usually this mu less than 1. Okay, that look like a fraction, but in some cases that can be greater than 1 value. Okay, but here mu equal F divided by R, then limiting coefficient of friction. When you consider limiting frictional force, then that mu we call limiting coefficient of friction. No? Limiting coefficient of friction. Continue. Do alone. Go one by one. Question number 2. Question number 2. A mass of 30 kilograms is rested on rough horizontal plane. It can be just moved by horizontal force 10 Newton. Here 300 Newton, mark reaction. Here P is just about to move when the force is 10 Newton. Then here friction F. Then F equal 10 Newton. When you consider vertical equilibrium, R equal 300 Newton. Find coefficient of friction. Mu equal F divided by R. 10 over 300, 1 over 30. And magnitude and direction of the resultant reaction of the plane. So here it is. Take lambda angle, take R dash. R dash equal 300 square plus 10 square root. No need to simplify, okay? Then 10, 901 Newton. Lambda tan inverse F divided by R. 10 over 300. Yeah, tan inverse 1 over 30. That is the direction of the total reaction. So that denoted by angle of friction. Continue. Continue one by one. Question number 3. A wooden block of weight W with plane base, it rests on rough horizontal plane. It's being pulled by a force P applied on the block in the direction which make angle 45 with the horizontal. It pulled, no? So now here wooden block weight W, mark reaction. Here it pulled with 45 inclination, 45 degree inclination, the force P. Then friction along the surface F. If the force P gradually increases, it begins to slide when P equal root 2 divided by 3W. Now it is in limiting equilibrium. Limiting equilibrium. So when you consider horizontal forces, P cos pi divided by 4 equal F. Then F equal root 2 over 3 W 1 over root 2. W over 3. Here limiting friction, frictional force. Then consider vertical forces R plus P sine 45 equal W. Then R equal W minus root 2 over 3 W 1 over root 2. 2W over 3. 2W over 3. So by that one we can find coefficient of friction, no? Then mu say F divided by R, F mean W over 3, R mean 2W divided by 3, then half is the coefficient of friction. Half is the coefficient of friction. Okay. Continue. You just continue one by one. Okay. Question number 4. Question number 4. A body of weight 40 kilograms is at rest on rough horizontal plane whose coefficient of friction 0.25. Newton, reaction R mu 0.25, here better write 1/4. Find the smallest force acting in the direction cosinus 3/5 with the horizontal, which cause the motion the body. So here one angle given cosinus 3/5, then cos alpha 3/5, then here alpha 3, 5, here 4. But here direction of the force not given. Find the magnitude and direction of the resultant reaction plane thereafter. So here we need to find the smallest force. Find the smallest force, no? Okay. So here let's consider two cases. Here case number 1, you just give a force like this P, then friction appear like this, say F1. Now case 2, you consider here 400 Newton, reaction R. So mark force P like this, same inclination, now friction opposite direction. Okay. So the direction of the force not given. There can be difference, no? So P, two different directions we can give. But when you push, it's somewhat hard to move, no? When we pull, then that is easy to move. Therefore, here the case that what we need, but we have to discuss both. Let's see, discuss both. Here case 1, you consider horizontal force, what? Okay, consider vertical force, then R plus P sin alpha equal 400. Then R sin alpha 4/5. Then P cos alpha equal F1, say F1, here F2, here P1, here this is P2, then R1, here better to mark R2, second case, no? Then P cos alpha 4/5 equal F1, okay? Then here say P1. Then here F equals mu R, no? So take F equals mu R, then F1 value 4P105. Mu mean 1/4, R mean here 400 minus 4P105. Check it again. Cos alpha 3/5, no? Then here 3. Now here we can find P1 value. You find P1 value for that case. Simplify this. Then 3P105, 100 P105. Then you put this one here, 4P105. 4P105 equal 100. Then P1 value 25 times 5, 125. Now the force 125 newtons. Now you go same path for case 2. Here case 2. You have to consider both because the direction of P not given. Then you have to analyze both. Then consider case 2. Then consider horizontal force P2 cos alpha equal F2. Then P2 cos alpha 3/5. F2. Vertical force R2 equal 400 plus P2 sin alpha. Yeah, this is case 1, okay. Then R2 400 plus P2 sin alpha 4/5. P2. Okay. Now again you consider F equals mu r there. Consider F equals mu r. Then 3/5. P2 mu 1/4 R2 400 plus 4/5 P2. 4/5 P2. Now we can simplify that. Now we can find P2 value. Simplify this. Here P2 cos alpha equal F2. Okay. Then 3 P2/5 100 plus P2/5 2 P2/5 equal 100. Here P2 value 250 newtons. 250 newtons. Now here when you consider case 2, it's somewhat hard to move. No? Pushing somewhat hard, but pulling easier than pushing. Huh? Then here smallest force required. Therefore smallest force 125 Newton. We have to pull it. No? We have to pull it. Okay. Complete it. Check simplification. Do alone. Question number 5. A particle of mass W is pulled along rough horizontal for rough floor. Here angle theta, force P, mark reaction R, friction F. So as according to the moving tendency, you have to mark direction of the friction, okay. The angle of friction lambda. Then here given mu equal tan lambda, no? So now it is known. Prove that the minimum force required to move the particle. Now consider horizontal force P cos theta. P cos theta equal F. Consider vertical force R plus P sin theta. R plus P sin theta equal W. Okay. Now here R value equal W minus P sin theta. then here 1, here 2. Then by 1, P cos theta equal mu R, no? Then P cos theta, mu mean tan lambda, R mean W minus P sin theta. Now you subject P. Then P cos theta sin lambda over cos lambda, W minus P sin theta. W minus P sin theta. Then P cos theta cos lambda, W sin lambda, P sin lambda sin theta. Now subject P cos theta cos lambda plus sin theta sin lambda equal W sin lambda. Here cos theta minus lambda. Then P equal W sin lambda divided by cos theta minus lambda. Then W sin lambda sec theta minus lambda. That is the force. Okay, so we have just trigonometric simplification there. Then you have to practice it. General trigonometric simplification. Here mu equal tan lambda. You have to consider that mu equal tan lambda because angle of friction given. Then by that one you find coefficient of friction. Thereafter we mainly consider about equilibrium condition. So equilibrium condition means no resultant force, no? Then vertical upward forces equal vertical downward forces. Horizontal left side, right side forces equal, no? Then by that you find. State the value of theta which the force minimum, find the value of, okay. Then for minimum P value, when P minimum, when we consider P minimum, okay, then we have to vary theta, no? Here this is theta, no? Therefore P minimum cos theta minus lambda must be maximum. That must be maximum. So that is maximum value 1, no? Therefore cos theta minus lambda value is 1 now. Then that happened for 0 value. Then theta equal lambda. When theta equal lambda, then we get minimum P value. When theta equals lambda, that we get minimum P value, okay? Okay, and let's complete question number 6 and then we can move to past papers. Question number 6, check your answers. Question number 6, a body is in limiting equilibrium on rough plane, inclination 30 to the horizontal. Now here it is, 30 to the horizontal. Find the coefficient of friction between body and the plane. Okay, now here weight W, mark reaction R, then here friction opposite to moving tendency. Here 30, 90 minus, here 60, 30. Now it is in limiting equilibrium, no? Resolve perpendicular to the surface. R equal W cos 30, then cos 30 root 3 over 2, F equal W sin 30, W over 2, then mu F over R, W over 2, root 3 W over 2, 1 over root 3. That is coefficient of friction. Complete, then we can move to past papers. Here this case working rule very simple. So first you have to mark forces. Then you consider equilibrium conditions. No? Usually along the surface you resolve, and perpendicular to the surface you resolve forces. Then no resultant force will appear. For limiting equilibrium, we can take F equals mu r. No? For limiting equilibrium, we can take F equals mu r. Otherwise, you can't take. You don't take. Okay. Now, another special one. For equilibrium, mu greater than or equal F divided by r. That is very special condition. Still, we haven't checked that one. But in your A-level questions, from 2019 to 2024, all A-level questions. So your syllabus start 2019, no? Then 2019 to 2024. So we can see inequality, no? We see inequality. Inequality means that one, mu greater than or equal F divided by r condition. Then 2018, 2017, 2015, again inequality type, no? Inequality type. Then 2000 to 2010 question not belongs to that type inequalities, but it contains some advanced cases, but for our A level we don't get advanced questions, so that usually part A type question, very simple question. Okay, but we have to practice up to that. Okay, let's start. Move to 2012 A-level question. Okay, read and sketch it. 2012 A-level question. First you read and sketch diagram and mark all the forces. 2012. Take time. Okay, 2012 question. If you have any doubt, do with me, others do alone. A uniform rod AB of weight W and length 2A is in equilibrium with one end A on rough horizontal ground, and the end B against smooth vertical wall which is perpendicular to the vertical plane containing the rod AB. Coefficient of friction between the rod and the ground, root 3/2. 3/2 whole thing root. Find the inclination of the rod horizontal when it's just about to slip. So now here it is given, here rough surface, no? Then moving tendency away the wall, then friction F, reaction R, here reaction R, mark R1 and R2, weight W, length 2A, AA, then mu given 3/2 root, here just about to slip, about to slip. That means limit in equilibrium, no? Then F equal mu R. You can take this one for this case. Then mu mean 3/2 R. Say R1. Mu R1. You can take that one because given limit in equilibrium. Now find the inclination, no? Then angle theta. We can resolve vertically. R1 equal W. It is in equilibrium. No? Then here by 1 you find F. F equal root 3/2 whole thing root W. Then resolve horizontally, R2 equal F. R2 equal F. Now all forces are known. No? Now to find inclination, you take moment about A. Take moment about A. So when you take moment about A, you can neglect F and R1. Then W, here A perpendicular length, A cos theta. R2 into, here 2A perpendicular sin theta, 2A sin theta. When you consider vertical one, here A cos theta, no? Then for horizontal one, 2A sin theta. Okay. Then W, here multiply, cross multiply, tan theta, W over 2R2, W over 2R2, R2, W. Then we can find this now. Then theta tan inverse 1 over root 6. Check simplification. 1 over root, tan inverse 1 over root 6. Then you go to 2013 A-level question. 2013. Take time. Two 2013 question, check your answers. 2013. A system given. No? So anyway, you need to mark all the forces. Now here the diagram. Here two strings T1, T1, T2, T2, block weight W1, reaction R1, friction F. Then here weight W2, inclination alpha. Now we can see two objects now. Then you resolve forces. Take here W2, vertical force T1 cos alpha equal W2 over cos alpha. Resolve horizontally T1 sin alpha equal T2 W2 over cos alpha into sin alpha, then W2 tan alpha. W2 tan alpha. No need to think too much. You just resolve forces. If the body is particle, you need to resolve the forces. If the body is rigid body, then you can resolve forces and as well as you can take moment. No? Now here these are particles. Then we need to just resolve forces. Now go to W2 load W1, resolve vertically R1 equal W1, resolve horizontally T2 equal F, T2 equal F, then T2 equal W2 tan alpha, F equal mu R1, that is in limiting equilibrium now, that is in limiting equilibrium, then put mu R. then W2 tan alpha mu R1 equal W1. Then simple part. Then got 2014. These are part A standard questions. Move to 2014. Here horizontal, here inclined plane, inclination alpha. Here a sphere. Okay, let's start. Now here, say this one, 2014 A-level question. Here reaction passing through the center, friction opposite to the motion F, here tension T, weight W downward, okay. Here tension and weight meet at this point now. Therefore friction and reaction resultant must passes through that point. Then here we call angle of friction lambda. Since here these two are radius, this also lambda, no? Lambda. Then here 90 minus lambda, here also 90 minus lambda. And here alpha, then angle sum 90 minus lambda times 2 plus alpha 180. Then 2 lambda equal alpha, lambda equal alpha divided by 2. Okay. Then by geometry you can obtain it. Okay. Now further we have to show that the angle of friction, thereafter we need to find tension in the string. Then you can resolve horizontally and vertically. You consider F R, here R1, take R1, okay. Then to find tension, better take moment about this point. Let's take this point A, let's take this point B, say C, then take moment about C. Then W into, here radius A, no? Radius A. Here 2 lambda, then A sine 2 lambda. Na? Here lambda addition 2 lambda here. 2 lambda. Then A sine 2 lambda. Then tension times perpendicular length. Sketch perpendicular here. Here A cos lambda. 2A cos lambda times, here A cos lambda, 2A cos lambda, again resolve. Here 90 minus lambda, here this will be lambda again, cos lambda. Equal now. Here A cos lambda, total 2A cos lambda, again you resolve. Then 2A cos lambda, again cos lambda. Now simplify. Then T equal W sin 2 lambda, 2 sin lambda cos lambda, divide by 2 cos square lambda. T equal W tan lambda. T equal W tan lambda. That is the value. Okay, complete. That is 2014 question. Not given W tan alpha 2 lambda equal alpha 2 na? Okay, then let's move to question number 2015 A level question. 2015 A level question. Now here a uniform thin heavy rod rests on one end, rough horizontal floor other end against smooth wall, vertical wall. Rod lies in vertical plane perpendicular to the wall, making angle acute angle theta with the wall. Theta with the wall. Now here theta, here rough, reaction R1, here reaction R2. Then here take F, weight W. Then you better to show forces are concurrent. Here forces are concurrent. No? Okay. Then you try to find F and R. Resolve vertically. R1 equal F. Take moment about, here take A, B, take moment about A, W into, here A sin theta, R2 into 2A cos theta, 2A cos theta, then R2, W over 2 tan theta, W over 2 tan theta, R2 value. Then again resolve horizontally, F equals R2, W over 2 tan theta. Then if the system is in equilibrium, for equilibrium, mu greater than or equal F divided by R. Here it not says that is in limit in equilibrium. Okay, it not given. Then you don't take F equals mu R. Then to be in equilibrium, this must be happen mu greater than or equal F or R. Then mu F mean W over 2 tan theta, R mean W. Then mu greater than or equal W over 1 over 2 tan theta. Very simple question, okay? Then first you mark forces, then resolve horizontally and vertically and take moment. Okay, if there's a rigid body, then we better to get moment. Huh? We better to get moment. Then resolve vertically and horizontally, take moment about A, then find all the forces, and to be in equilibrium, mu greater than or equal F divided by R. Okay, continue. Okay, then 2017 A-level question. Here part B standard 1. Here there's a hinge uniform cubic block of weight W and rod 2W, length 2A. Here A 2A, and take theta, sin theta A divided by 2A, then theta pi divided by 6. Then here there will be reaction R1, R1, then here hinge mark Y and X, then moving tendency outward, then friction F. Okay. Now here we have to get inequality, then don't take F equals mu R. So we have to consider mu greater than or equal F divided by R relation. Now you have to find here F and R. You take another R here. Then consider block. Cubic block. Vertical forces R equal W. Then to find F, need to get R1. Then consider rod. Take moment about A. Here A. Then 2W over A cos theta. R1 over 2A sin theta. R1 over 2A sin theta. Here 2W over A cos theta, R1 into 2A sin theta. Then you can find R2, W cot theta. W cot theta, no? Then theta mean pi divided by 6, no? Root 3W. Theta pi divided by 6. Then we know R2, then resolve horizontally, R1, no? R1 equal F, F equal root 3W, then to be in equilibrium, mu greater than or equal F divided by R. Then we know F and R, no? Then mu root 3W divided by R, mean W. Mu greater than or equal root 3. Simple question. First you have to mark forces. Then equilibrium condition, mu greater than or equal F divided by R. Then friction appear here. Then you find R and F. Okay, then 2018, a uniform rod AB weight W, length 2A, has in A placed on rough horizontal ground and B against smooth vertical wall. A, B, reaction R1, friction F. Weight W. Here reaction R1. A particle of weight W. Here AB. You mark here WC. Here AC distance X. Rod inclination theta to the horizontal. Tan theta 3/4. 3, 4, 5. 3, 4, 5. Now ACX now. Now the coefficient of friction 5/6. So anyway here we have to get inequality. We take that one using mu greater than or equal F divided by R, no? Okay, then you find F and R. Resolve vertically. R1, here R2. R1 equal 2W. Take moment about A. W, here A, no, A cos theta plus W, here X cos theta. R2, 2A sin theta. Then R2, WA, W cos theta, A plus X divided by 2A sin theta. W over 2, A plus X, tan theta, here tan theta 3 divided by 4. Two W A plus X over 6. 2W over 3. R2 value. You find R2 value. Two W A plus X over 3. R2 value. Then F equals R2. Then F equals R2. Now you can get the inequality. Now inequality mu greater than or equal F divided by R. Here no need to put modulus because usually we know F value positive. Then mu 5 over 6 F R R1 to W. Now simplify. Here 3A, 5 over 2 A plus X over A. 5A, 2A plus 2X, 3A, 2X, 3A over 2 greater than or equal X. That is 2018 question. Anyway, first you sketch the graph, mark forces, and inequality obtained by mu greater than or equal F divided by R. Then to get that one, we firstly need to find forces. Resolve and take moment. Resolve and take moment. That's it. Okay, now let's move to 2019 question. Then 2019 onwards, new syllabus. So we have double inequality all cases. So double inequality we obtain by modulus sign, mu greater than or equal F divided by R modulus. We need to put modulus for F. So because of that we get double inequality. But anyway, you just remember this one. Think this. Here modulus X less than 1 idea, X in between -1 to +1. Okay. Then modulus X greater than 1 mean X less than -1 union X greater than 1. Here this is our idea. Modulus X less than 1 mean X within -1 to +1. -1 to +1. You have to remember that. Okay. Then consider X minus 2 modulus less than 1 mean X minus 2 in between -1 to +1. Then you can add both sides 2, -1 plus 2, X 1 plus 2. Likewise, we can evaluate 1, X 3. Likewise, we can evaluate, okay? So this is modulus special case. modulus special case, okay? Now, by that relation, we're going to get double inequality. But remember, modulus x minus 1 less than x, less than modulus x, you don't do that way. Here we have two variables both sides now, but here we have one variable only left side or right side, but here constant and other one variable. Then you do that relation only for this. Don't do x minus 1 plus x minus x. Don't do this one. Only for this one, you just do. Okay. This is modulus inequality. Now go to 2019 question. 2019 part A level question. Here let's see. Here W divided by 2. Here W. Here R. Here friction F and force P. Okay. Now with the value of P, here F can be differ, no? Here for small values, it has tendency to move away from the wall. For small p values, it has tendency to move away from the wall. Therefore, friction, this is correct. But some larger values, it has tendency to move towards the wall. Then friction will be opposite, no? Therefore, with the value of p, direction of can be differ, no? So, but all the previous cases, now see here this case, surely we can say it moved away the wall. Then surely F positive, that's why we didn't put modulus here. But this case, we have doubt here, no? Then we have to put modulus. Okay. Now let's see. First resolve vertically. R equal W. Then resolve horizontally. F plus P equal W over 2. Then take moment about. Here take this point A. Here B, no? Here R equal W, P plus F equal W over 2. Okay. Now here F equal W over 2 minus P, no? W over 2 minus P. Then to be in equilibrium, mu greater than or equal F divided by R. Here you have to put modulus because sign of F we don't know exactly. Okay. Such case you have to put modulus. Okay. Then mu value given 1/4 F W over 2 minus P modulus R value W cross multiply, then W over 2 minus P mod W over 4. Here we better to interchange these two. So here this case it look like this. Then you directly write double inequality. P minus W over 2 in between minus W over 2 and plus W over 2. Here P only variable, W are constant. Therefore we can directly write. Now each case you add W over 2 now. Here W over 4, no? In between W over 4 minus W over 4. Now to subject P, you add W over 2 both sides. Minus W over 2 for W over 2 P W over 4 plus W over 2. Now we can get the answer. Then P value in between, here W over 4 and here 3W over 4. 3W over 4. Then same type question, but here we need to think one thing, that is modulus inequality relation. Okay. So anyway, you mark forces by resolving and taking moment. You find them. Then double inequality here modulus, because we don't know exact direction of F. That's how you put modulus here. Then after getting modulus inequality, you solve this way. Okay, you better note this one. Complete. Here the sign change, that not compulsory. But here P variable now, we better to get positive coefficient. That's why I interchange these two. Within modulus we can do anything. Within modulus we can change sign. Then no issue. Okay. Now go to 2020. Go to 2020. Here pi divided by 4, where W, reaction R, here force P given, F given, but with the value of P, direction of F can be different. No? With the value of P, F can be different. Okay. Therefore, first you resolve perpendicular to the plane R, W cos pi over 4 plus P cos pi over 4. W plus P over root 2. Then along the surface, F plus P sin pi over 4 equal W sin pi over 4. W minus P over root 2. Then F divided by R, W minus P over root 2, W plus P over root 2. Then W minus P over W plus P. That is FOR. That is FOR. Okay, then get double inequality. Okay, then to be in equilibrium, mu greater than or equal F divided by R. Here you have to put modulus, because we don't know exact direction of F. No? There you have to put modulus. Now continue. Mu value half modulus F. W minus P, W plus P. Here modulus effect here, because W minus P, this can be positive or negative with the value of P. Then modulus effect here, affected here. Here. Here plus or minus. P value greater than or equal to W over 3. Here 3W P. Therefore, you can say P in between W over 3 to 3W. Complete. Go to 2021. Here the figure. Lambda mg, tension T, mg, R, F. Here Q and P. Then Q vertical forces T equal lambda mg P along the surface T equal F plus mg sin pi divided by 4. Mg sin pi divided by 4. Here lambda mg F mg over root 2. Then by that you find F. The result take P perpendicular to the surface R equal mg sin pi over 4. Mg over root 2. Then to be in equilibrium, mu greater than or equal F divided by R. Yeah, put modulus because with the value of lambda, the motion moving tendency can be changed. Mu given half, F value mg lambda minus 1 over root 2 modulus mg over root 2. Then simplify. Then 2 lambda minus 1 in bit root 2 lambda minus 1 in between minus half to plus half. Then add 1. Now divide by root 2. Okay. Complete. Okay. Then let's move to 2022 A-level question. 2022 A-level correction friction 1. Do with me. 2022. Here is figure given. So here angle pi divided by 4. Here is, here at the midpoint weight W and force P given. And here R, reaction, friction upward F. Then mu given 1/6. Mu given 1/6. Then this is also very simple question, part A type question. Now, first you have to, here this is rigid body now. Then you can resolve forces and you can take moment. So anyway, we have double inequality. Then double inequality appear because mu greater than or equal F divided by R condition. With the value of P, here ladder can shift towards the ball or away the ball with the value of P. So therefore this frictional force direction can be differ, can be upward or downward. Then mu greater than or equal F divided by R, we need to put modulus for F because F can be changed, no? So anyway, consider vertical forces F plus S equal W. Consider horizontal forces P equal R. Then take moment. So let's take moment about, here, let's say point A, point B. I'm going to take moment about B. Then W times here A cos pi of 4 plus P times A sin pi of 4. Here S times 2A sin pi of 4. Sin or cos, whatever it is, okay. Cos pi of 4. Because angle 45, no? Then sin cos, whatever it is, okay. Then P positive, W positive, S negative. Then put equal. Then A cos pi of 4, you can cancel. Then W plus P equal to 2S. Here third relation. Now we have three relations. Okay, now here this S value, put it here. Then W plus P to S. S equal W minus F. Then here W, 2W, W. P equal W minus 2S. W minus F, no? Here W minus F. Then 2W, W minus 2F. Then W plus P, 2W minus 2F. Then F equal W minus P divided by 2. Then to be in equilibrium, mu greater than or equal F divided by R, you need to put modulus here because direction of F can be changed, no? Then mu value given 1/6. F value here W minus P modulus over 2. R value is P. R value is P. Now you can simplify this inequality. Let's do. Then here cancel 2 and cross multiply. P. Here 3. W minus P modulus. Then 3. P minus W modulus less than or equal P. Now here we have double inequality, no? We have double inequality. So then you can write within 3 P minus W within minus P and plus P. Then take these two together, minus P, 3 P minus 3W, and take these two together, 3P minus 3W less than or equal P. Now here 2W P 2w divided by 3. Here 3p. 2w divided by 3. No, this is, sorry, here 2w, 3p. Then p, 2w over 3. Interception, here 2p, 3w. 3w over 2. 3w over 2. Check it again. Something wrong, no? Something wrong. Here f plus s equal w, p equal r. About b moment, pa cos 45, pa sin 45, 2s cos 45, then 2s w plus p, 2s, s value f minus w minus f, then w plus p, 2w minus 2f, then f value equal w minus p over 2, then mu greater than or equal f divided by r, w minus p over 2 divided by r equal p. Here r equal p. Then here 3 now. Then here cross multiply p, 3w minus p, 3p minus w, p, then 3p minus w in between minus p to plus p range. Then split this one, minus p, 3p minus 3w, interception, 3p minus 3w less than p. Okay, here this is wrong now. Here 3w, 4p. Then here p, 3w divided by 4. Now it is correct. Now here 2p, 3w over 2. Okay. Then anyway, by combining these two, you can write 3w over 4, 3w over 2 within 3w over 4 and 3w over 2. That is 2022 A-level question. Very simple question. So you have to consider about double inequality. No? You have to consider about double inequality. Okay. Then let's move to 2023 A-level question. 2023 A-level question. So here given figure, here pi divided by 6, mass 2 mg, r, here friction opposite F, here tension T, tension T, tension T, tension T, here QP, here mg. So according to this diagram, definitely Q has moving tendency downward, therefore P moving tendency right side. No? Then friction definitely positive value, that way, that direction. Then no need to put modulus here. For inequality, no need to put modulus because the direction fixed. Now anyway, consider Q, vertical forces T equal mg. Then consider P, vertical r plus T sin pi over 6 equal to mg. T mean mg, 1 over 2 mg. Then r equal 3 mg divided by 2. Then resolve horizontally. F equal T cos pi over 6. T mean mg, cos 30 root 3 divided by 2. Then to be in equilibrium, mu greater than or equal F divided by R. Here no need to put modulus because the direction of it is definite direction. No? Then mu value greater than or equal F mean root 3 mg over 2 divided by R, 3 mg over 2 then mu greater than or equal 1 over root 3. 1 over root 3, very simple question. That is 2023 A-level question. Okay, 2024 A-level question. 2024 A-level question, the figure given, here the figure now. Here hinge, root 2W force, then here reaction R, the friction F, given P force, here 45-degree inclination, here 2W, here it is, A, B, C. Now consider AB rod, consider vertical force R plus root 2W sine pi over 4 equal 2W. Then cancel R equal W. Then resolve horizontally. Then F plus P. F plus P equal root 2W cos 45. Then F value, here F value equal W minus P. F value W minus P. Okay. Then we know R and W. Now to be in equilibrium, mu greater than or equal F divided by R. Here we have to put modulus. Here because here F direction can be differ with P value. No? Then mu value given, it is 1/4. F value W minus P modulus R value is W. Now here 1/4 W divided by 4 less than or equal, you better write here P minus W modulus. Then here double inequality, we can write now P minus W now in between minus W over 2 to minus W over 4 to W divided by 4 with equal. No? Then add both side W, then minus W over 4 plus W, P, W plus W over 4. W over 4. Now further you simplify this, then you can get the answer. Here 3W over 4, here P, 5W over 4. 5W over 4. That is 2024 A-level question. Okay, then that's all for today. This is 2024 question. You do these questions again and again and practice the remaining questions. Okay, that's all.